Hi everyone. So today we're going to discuss a genuinely amazing question. And what's so beautiful about this is that things like Euclidean division algorithm, right? What we're going to talk about in today's video, things like Euclid's division lemma. These are the first things that you study when you start off with number theory, right? These are one of the first things that you start off when you start off with elementary number theory. But what's so really beautiful about mathematics is that some really amazing questions can be made just from these elementary concepts that you might study in grade 9, grade 10th, right? Very early on in your life, right? And very amazing questions can be made based just upon these elementary concepts. And this is a classic example for that. And to this day, this question is probably one of my most favorite questions. And that is exactly what we're going to discuss. So let's just get right into this video. So this is the problem number 4 from the Bangladesh National Math Olympiad in the year 2013. And in this video, we're going to talk about the Euclidean division algorithm. We're going to talk about minimizing a fraction. Essentially, that's the goal of the video actually. And then we are going to look at book sessions for National Math Olympiad, and at the end, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so it's given to me that if the fraction a by b is greater than 31 by 17 and b is less than 17, find the minimum value of a by b. It's just as simple as that. You know, this can be considered a puzzle question as well, but we're going to obviously use certain formal arguments to go about this, right? And okay, let's just begin, right? So it's given that a by b is greater than 31 by 17, and we're going to form certain bounds over here. We're going to use a little bit of bounding to kind of get to our original, some of our few original results, right? Now, a by b is greater than 31 by 17, and 31 by 17 is obviously greater than 1, right? It's 1 point something something. Now, similarly, this is also less than 2, right? Because 31 by 17 will be less than 2, or a better way to probably write this would be that this is going to be less than or equal to 31 by 16, because b is less than 17, so it's going to be less than or equal to 16, and this is obviously less than 2. So basically, what conclusion we can form is that 2 is greater than a over b, which implies that 2b is greater than a, right? Because we're dealing with natural numbers, positive quantities over here, right? Similarly, a by b is greater than 1, what I told earlier, so that essentially implies that a is greater than b. And right off the bat of that, we can actually make certain cool observations, right? So we know that a is greater than b, but if I add this b, another b over here, the sign of the inequality actually flips around, right? A is less than 2b. So starting off with a and b, two numbers, well, we can say that a is greater than b, but if you add another b, if you add b plus b, which is 2b, that's actually going to be greater than a, which is absolutely fascinating, right? Okay. Now, because of the fact that a is greater than b, I can write a is equal to bk plus r, right, from the Euclid's division lemma. Awesome. And we also know that this remainder r, this remainder is between 0 and less than or equal to b minus 1. Well, it's less than b, but less than or equal to b minus 1. Okay, amazing. Now, from this observation that I just talked about a little bit, right, a is greater than b, but if you add another b, a will be less than that, right? The sign of the inequality flips. So k can only be 1. Because if k is 2, for example, if k is 2 or any higher value than that, what will happen is that a is equal to 2b plus r. But that can never be true because a is less than 2b. So how can a be greater than 2b? Right? Because if a is 2b plus r, that means a is at least 2b if not greater. Similarly, if a is 3b plus r, a is at least 3b if not greater. But that cannot be true, right? Because like I said, if we add another b, a is less than that, right? That was very fascinating. So k can only be equal to 1, right? Pretty cool, isn't it? So a is actually nothing but b plus r. And if I just divide by b on both sides, I'll get a by b is equal to 1 plus r by b. Very cool, right? And what's fascinating is, what is our goal? Our goal is to minimize this value of a by b. Minimize the entire fraction. Minimize the entire fraction a by b. So minimizing a by b is effectively equivalent to minimizing r by b. Because whatever this minimum value of r by b is, add 1, you get the minimum value of a by b. So effectively, we just reduced to minimizing this r over b. And what is this r over b? It's nothing but a over b minus 1. just by subtracting 1 from both sides. Now, R over B will then be greater than 31 by 17 minus 1, because A by B is greater than 31 over 17. Right? That's the condition given to us. A by B is greater than 31 over 17 and B is less than 17, and we need to find the minimum value of A by B. Right? So if A by B is greater than 31 by 17, R by B will be greater than 31 by 17 minus 1, or effectively R by B will be greater than 14 by 17. And obviously B is less than 17. Right? So again, like I said, we just need to minimize this value of R by B, and we would have received the minimum value of A by B. Okay, amazing. And just to remind you, we had this bounding on R from our Euclid's division lemma, which was it's between 0 and B minus 1. Right? We have this inequality. So what I'm going to do is I'm going to let R is equal to B minus X, where obviously X is a real number. Right? Or equivalently, I can just state that X is B minus R. Right? From making X the subject of this quantity. Now let's fix certain bounds. We know that R is between 0 to B minus 1. So what will be X? X will be less than or equal to B. Right? You just plug in R is equal to 0. And when you plug in R is equal to B minus 1, you'll get that X is greater than or equal to 1, which is fascinating, right? We have this bound on X. Now we had this inequality, R by B is greater than 14 by 17, and we need to minimize R by B, right? And I'm going to replace R with B minus X, right? Like the substitution I made over here. R is equal to B minus X. So B minus X over B is greater than 14 over 17. Okay, really cool. So 1 minus X over B is greater than 14 by 17, and I'm just going to make X over B the subject. So when I make X over B the subject, I'll get X over B is less than 3 by 17. Or equivalently, I can just state that X is less than 3B by 17, but B is in fact less than 17. Right? So X is effectively less than 3. Right? That makes sense because B is less than 17. So 17 get cancelled out. So X is effectively less than 3. But if you actually notice, X is greater than or equal to 1. Right? So we have this inequality. X is greater than or equal to 1, but X is less than 3. So therefore, X can either be 1 or 2. Right? It can be 1, it can be 2, but it can't be 3. It's less than 3. Right? And if X is an integer, X has to be 1 or 2. It can't be anything else really. Right? Okay. And we just split this up into two cases, right? Case 1, X equal to 1, and case 2 is X equals to 2. So just to remind you, what was R? R was B minus X. Right? R was B minus X, and we had to minimize this fraction R by B such that R by B is greater than 14 by 17. And we had to minimize R by B. It's very important to kind of keep the end goal in mind because it's very easy to get swayed away from that. But okay, if I just take X equals to 1, so R becomes B minus 1, pretty clear. So B minus 1 by B is greater than 14 by 70. Now that's absolutely amazing because we were dealing with A, B, R, X, whatnot, right? But now we have just one variable, right? It's just solving an inequality in one variable, right? This is very elementary. This anybody can do. So you get 1 minus 1 over B is greater than 14 over 17, which is amazing. So what will 1 over B be? 1 over B will be less than 3 by 17, right? Or effectively B will be greater than 17 by 3, but because B is an integer, B is greater than 5, right? Because it can't be equal to 5 because obviously 5 is less than 17 by 3. 17 by 3 is something like 5.67. So B has to be greater than 5. So therefore B has to be at least 6 or greater. But if you actually notice something, this B minus 1 over B was R by B, right? B minus 1 by B, I can write it as 1 minus 1 over B. Now, there's a very cool observation over here. If I keep on increasing this value of B, right? If B keeps on increasing, 1 by B keeps on decreasing, right? As the numerator keeps increasing, the fraction keeps decreasing. As the denominator keeps increasing, the fraction keeps decreasing, right? So if I increase B, 1 by B will keep on decreasing. That means that you are subtracting a smaller and smaller quantity. What that means is B minus 1 over B is increasing. So B minus 1 over B, which is equal to R by B, is increasing as we increase B. Right? So what does that mean? And we need to find the minimum value of R by B. That's the critical point. The critical point is that we need to find the minimum value of R by B, but R by B is continuously increasing as we increase B. What does that mean? That means the minimum value of R by B will be where B is minimum. That is completely amazing, right? Because if you think naturally, the maximum value of B will be where R by B is minimum, right? That's the natural inclination because b is in the denominator. Yeah, but a little bit of more advanced analysis actually tells you that r by b is actually an increasing, it's an increasing thing, right? As we keep on increasing b, it's actually increasing because r is also effectively increasing. R is not a constant, r is effectively increasing with increasing b, right? And therefore this r by b, this b minus 1 by b, which is for case number 1, is increasing as we increase b. That means r by b will be minimized at minimum b, because if we just increase b, r by b is keeping on increasing, just increasing. R by b is b minus 1 by b, so b minus 1 by b is continuously increasing with increase in b, right? So it will achieve a minima at minimum b. And what's the minimum b? Minimum b is 6. So therefore b is equal to 6. What was r? B minus 1, so r is effectively 5. What was a by b? Is equal to 1 plus r by b, if you remember. So a by b, minimum value of a by b will be 1 plus 5 by 6. So a by b minimum will be 11 by 6. And that's for this case. And so for case number 1, we got the minimum value of a by b is 11 by 6. We'll check case number 2, and then whatever is the minimum value in these two cases, we'll just say that the answer, the least value, we'll say that it's the answer. Okay, awesome. So case A, we got a by b minimum is 11 by 6. Case 2, just x equals to 2. Right? Because if you remember, we had received x can only be 1 or 2. So just plug in x equals to 2. What was this r? R was b minus x, right? So r just becomes b minus 2. So effectively r by b becomes b minus 2 by b, which is greater than 14 by 17. Again, amazing. Just one variable, right? So 1 minus 2 over b is greater than 14 over 17. So effectively 2 by b is less than 3 by 17. And again, kind of using the same ideology, 1 by b is less than 3 by 34. So b is greater than 34 by 3. So b is greater than 11, like I said again, and therefore b is greater than or equal to 12. B is at least 12 or greater. But if you actually notice r by b, which was b minus 2 by b, I can write that as 1 minus 2 over b. Now again, as b keeps on increasing, this 2 by b will effectively decrease. Right? If I keep on increasing b, the fraction 2 by b will keep on decreasing, and you're subtracting a smaller and smaller quantity. That means that this quantity b minus 2 over b is equal to 1 minus 2 over b is increasing with increase in b. So it is increasing with increase in b because you're subtracting smaller and smaller quantities. So that means its minimum of b minus 2 by b, which is effectively r by b, will be at minimum b. Just the same ideology, literally the same thought process that we had done for case number 1. Same, it's the exact same. In case number 1, we had 1 minus 1 over b, but in case number 2, we had 1 minus 2 over b, but the concept of increase and decrease is effectively the same. Right? There's no change upon that. So minimum value of b, and where is the minimum value of b? B is minimum at 12, right? So b is 12. What was r? R was b minus 2, so this becomes 10. So a by b is equal to 1 plus r over b, 1 plus 10 over 12. So a by b is equal to 1 plus 5 over 6, and therefore a by b is equal to 11 over 6. And what do we really see from here? We see that both from case number 1 and case number 2, we get 11 by 6 here in case number 2 and 11 by 6 in case number 1 as well. So the minimum value of a by b in both cases 11 by 6. Therefore, we can effectively conclude that the minimum value of a by b is 11 by 6, right? So in the question that given us that a by b is greater than what it was, I think it was 31 over 17. It was, 31 over 17. And they had given us that b is less than 17. So if you actually check this out, you can check this out using calculator really or compute this. You can see that 11 by 6 is actually greater than 31 over 17. And b is obviously 6, so that's obviously less than 17. And actually that's the minimum possible value of a by b, right, for these two given conditions. And I think that's a fascinating problem. And that was a really good discussion, I hope. And you learned quite a few things, right? Even the most elementary things in number theory especially can be really made into some very interesting questions that you'll have to think through a lot, right? So I really hope you enjoyed that and learned something from it. Okay, so moving on to certain book suggestions for National Math Olympiads, we have Elementary Number Theory by David Burton, Problem Solving Strategies by Arthur and Gell, Functional Equation by Venkatachala, Problems in Plane Geometry by Sharigan, Elementary Number Theory by Sierpinski, graph theory by Harari, and combinatorics by Brualdi. Okay, so at the end we have a similar but challenging problem. And it's given to us that let a and b be integers such that they satisfy this given inequality and find the minimum value of b. Again, kind of like the similar concept. This is, I believe, an INMO problem. And such problems, we have seen them occurring a lot because it's so fundamental, it's so beautiful. You don't really need a lot of high level knowledge of number theory, a lot of really rigorous stuff that you need to know. It's just simple Euclidean division algorithm, Euclid's division lemma, and you can really proceed with this, right? So maybe try this out, and if you're able to do it, let me know. Until then, I'll see you in the next video. Thank you very much, and bye-bye.
Cheenta programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.